Welcome to lesson 4 of our digital graphics course, unit 30 for our Btec level 3. Today we're looking at optimization and optimizing what this means in terms of digital graphics. Okay, so let's get started. Optimizing, so basically it's a word that's used a lot in the design industry and many industries as well. Sorry, I'll put a capital and not a capital there. And basically, what does optimizing mean? What do we talk about when we're talking about optimizing a file? You need to optimize this. Okay, so we talk about optimizing something to get the most out of it. So basically, the definition of it would be to make something optimal, get the most out of it, use it to the best of its ability to optimize your resources. Or you could call it to modify to achieve the maximum efficiency in storage capacity or time or cost. Optimizing a computer program to get it to its maximum potential. So why is it important in the design industry? Okay, so basically limitations are everywhere in design. Okay, can you think of some of those limitations that you've got when we're talking about making digital graphics? What are we limited by? Okay, when we talk about what we've got when we make a graphic. So things like disk size, we're limited to the amount of space that we've got on our hard drive. How much can we store? Okay, so if we're making big graphics, sometimes some of the graphics I've made or the 3D scenes can be, 1 or 2 gig on their own. And then by the time I've started storing all the textures and files for it, I'm talking 3 or 4 gig. Okay, so you can fill a hard drive very fast. Download limits. So if you're sending to a client at the other end of it and they need something fast, it's going to take them a long time to download the file. It's going to take a long time to transfer. But also, if you're talking about web design and things like that, you can't have massive graphics that take somebody, a couple of minutes to download, or if a page doesn't refresh straight away or load up straight away, we're conditioned now to get impatient and believe that our time is being wasted and that we need to move on. Okay, so download limits. Okay, so people still in this day and age, all right, I might have 100 meg optical fiber, but some people are still working with, say, 5 meg broadband and so on. So you've got to consider everyone. Include that in download speeds. Obviously, the computer memory sometimes is going to be an issue, in your CPU power. Obviously, I don't necessarily need to explain those, but it's quite obvious. The more sort of demand we're putting on our computer, the heavier it's going to have to work. So therefore, we need to optimize our files to make sure we're not stressing our computer out. How quickly things load on our machines. And how accessible those files are. So what I mean by that is when you look through a million files to try and find the file that you saved that you called the final version, final 7, final, definitely this is final, how accessible is that? Could someone else pick up your computer if you were ill at work and find the file you were working on the day before? Which is the most up to date, which is the most relevant file? So those are all examples of optimization. Okay, so when we talk about game developers, they're always looking for ways to optimize their work so the games will run and look better. Okay, so there's numerous ways they can do that and basically optimize an image for its output. So you can think about bit depth, you can think about the way you compress, you can think about the dimensions of your image, you can think about the resolution of your image. Okay, so these are all really important things. So how big does my image need to be? Do I really need to make it 1000 by 1000 pixels if it's only going to be displayed as a background asset on the game or on the screen? Is it really vitally important that I do it? Do I need to save this image so big because it's only going to be, a little part of my poster or my collage? So before you optimize, okay, it's vital that you know the purpose of it. Okay, so what is it going to be used for? It's like I'm talking, because if it's going to be blown up really big to some kind of billboard or banner or something like that, of course you need to keep as much information as you can. It's vital because that image is going to be upscaled. It's going to need all the information it can get. But however, with that in mind, once you've done this, it's irreversible. You can't then unoptimize something that you've done. So once you've got that sub-quality, that lower quality image, you're stuck with that. So therefore, make sure you always keep backups. I can't stress that enough. Make sure you save versions of it. It's like working on one Photoshop file. Just keep working on it, and then it becomes corrupted, and you've only got the one version of it. Whereas if you're saving sort of every hour, my work 01, my work 02, my work 03. If 03 crashes, I can go back and use 02, okay? That is a really good process to get in the habit of doing, even if it's on a Word document and things. The amount of you that have probably had Word documents that have become corrupted and things like that. It's really good to save when you get to a different point and then save as and save a new copy so that you're keeping previous history examples. So bit depth, when we talk about what is a pixel, okay, so this is a rhetorical question here, but what is a pixel? We've covered that in lessons 1 and I covered it a little bit in lesson 2, okay? But what information does that hold? Okay, so hopefully you remember it holds the information about color. And what is a bit? Okay, so bit depth is essentially the amount of bits that are assigned to an individual pixel. Okay, and we will look at some examples of this. Basically, the more bits that a pixel has, the more data that pixel can store. And the more data it stores, the more color that we can have in our screen, the more options of color, okay, that we can have. So a bit can either be on or off. So nothing else. It's either on or it's off. So a single bit can hold two values. It's either turned on or it's turned off. The most basic pixel can either be on or off. Therefore, a single pixel holds at least one bit of information. Okay, so at least, if you're talking 1 bit, the most limited, the smallest amount of bit depth that you can have would be 1 bit, and that will mean either this pixel's on or off for color. So 1 pixel equals 0 or 1. So this image shows an image with 1 bit per pixel color. So we're looking at a black and white essentially with a bit of grey information there. There's not much information at all. We're looking at. So it's got one bit can show 2 colors. So we're not recognizing the black as a color. We're looking at the grey and the white. You see here? Essentially, it's black and white really. But so a bit depth, a pixel with higher bit depth will hold more data, so it has access to more colors. So an image with a bit depth of 2 bits per pixel can offer you 4 colors. Okay, so 2 bits per pixel can offer you 4 colors. So 3 bits per pixel can offer you 8 colors. You can see what's happening there. 2, 4, 8. We're doubling each time. If you've got 4 bits per pixel, so if each pixel can hold 4 bits of information, you've got 16 colors. 5 bits per pixel is 32 colors. 6 bits is 64. 7 bits 128. We're doubling each time. 8 bits is 256. So we're starting to actually get an image that represents close enough anyway to what it should look like in real life. Okay, so you can spot the pattern, hopefully. Those of us that know anything about maths here should be seeing that, but yes, we're doubling each and every time. So therefore, that would help us work. So if we use that, so we double, we double, we double, and we keep going. So 2 to the power of 8 is 256 that we're looking at. So if we keep doubling that way, how many would 24 have? So try and work that out. Okay, so if we do 2 to the power of 24, we're going to get the answer of 16,777,216 colors. Okay, and this is what we would call true color. This is what the human eye can process. Okay, well, we can't actually process all those colors, but it's something that we call true color. The human eye is programmed to condition to understand about 10 million colors. Okay, some of us it varies how many colors we can see, but true color is recognized as this 16.77 million. So it achieves this by mixing 3 colors, and we've looked at this before. So each color is made up of a combination of these 3 colors. So each one of those 16.77 million colors is made up of a certain combination of these 3 colors, red, green, blue. Now it might be 0 of one and a lot of the other 2, but it's always made up of those 3, RGB, red, green, blue. And each one of those has 8 bits assigned to it. So 8 plus 8 plus 8 is 24. So you've got 8 bits for every red color you're using, 8 bits for every green color you're using, and 8 bits for every blue color you're using, hence 24 bits per pixel, offering 16.77 million. So as an activity, if you do wish to do it, pause the video now, excuse me, but go online, try and discover the amount of colors that the following game consoles were capable of displaying, and now what they could display simultaneously, not what they could display simultaneously. So how many could they display? So here's some answers. Let's go through. So we've got the Atari 2600, the Master System, NES, Mega Drive, SNES, Game Boy Color, PlayStation. So you can pause it if you want, and let's look at the answers. So if we look at the PAL version, which is the European version, the Atari had 104 colors. It was capable of displaying. Master System 64. NES was 48 colors, and it had 6 different grays, which wouldn't class as a color. Mega Drive is 512. SNES is 32,768. As the Game Boy, and the first true color machine was the PlayStation at 16.7 million colors. Okay, so compression. Okay, so what is compression? This is what we've looked at. What are 2 types of compression? What does lossy compression do? What does lossless? Those are all things now that you did in the previous lesson that hopefully, if you asked yourself these questions, you'd be able to do. So I'm taking your comprehension here. Ask yourself these questions, see if you still remember them. Hopefully you will. This is the information you need to retain that we're going to put into our assignment, okay? When we talk about dimensions in a screen, okay, so hopefully you know dimensions. What are the dimensions of this image, okay? So basically, what's a you should be able to say what is the difference in dimension and resolution. So if we look at dimension, the size and the scale of an image is vitally important, okay? So if you're designing a piece of promotional material, you need to know the size of the target output. So if someone told me that this Battle 3, I mean, you can tell how old this is, but you're making a billboard, okay, I need you to make an image for a billboard. My first question is, how big is the billboard? Because I need to know how big the image is. It's no good me just guessing and making an A4 size image and then stretching it across there. I don't want that to be stretched or distorted in any way. I need to know exactly how big the image is going to be, okay? So that gives us that information. So we're sticking on our information here. So dimensions would be how big is it in height, how big is it in width. So, you know, it might be 6 meters by 3 meters or whatever this version would be. That would be my dimensions, my sizing. Okay, and that is our fourth tutorial finished for our theory base. We've only got one more of these theory based tutorials to do, so hopefully you're following along pretty well. If you've got any information that you need, please do ask questions. Thanks very much. Bye.